All right, good evening, everybody. In this particular video, we're going to talk about the average rate of change, which deals with obviously speed can be one factor in average rate of change. Rate is kind of something we predominantly use unit rates, which we discussed in class today, which is like miles per 1 hour, or we talk about price per 1 pound. Heartbeats per minute. Everything kind of we use is unit rates, and we'll kind of use the same kind of comparison here. But for the most part, we're going to kind of have a general conversation on how this formula works. Average rate of change, that is the f of b minus f of a divided by b minus a. And for most of you guys figured out today the averages of things, okay? But today we're going to talk about the average rate of change. Okay, so the first thing I want you to do, and this is similar to the problems you have on your paper, is let's graph this equation. So we've been learning this, and so this should be something new for us. Let's go. Horizontal movement is 5, 1, 2, 3, 4, 5. Up 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way at the top. All right, and then I'm going to, because it's just negative out in front, or the front number is just -1, so I'm going to follow the same pattern as I always do. Down 1 over 1, down 3 over 1, and of course you guys are probably mimicking the same thing you're saying. Down 5, 1, 2, 3, 4, 5 over 1, and I can continue going on. I can go down 7, but for the most part my journey is done. All right, and so if I graph that function there, eek, this is not good. I'm gonna try one more time. Get it? Yep. All right, that'll do. And then the other side. All right. So if you're struggling with graphing equations, you need to get that down first, and that's also on the videos there if you need to review that concept. So here's my general graph of this, and so I've done check A off. All right. Now I want to find the average rate of change between 3 and 6. All right, to do that, let's use this formula here, and you can, like I said here, use the graph to help evaluate the function at the given point. So let's, I'm going to fill in that graph with that material with the things that I want. So B stands for the second number, similar to the graphic here. So if I have f of 6 minus f of 3 all over 6 minus 3. Now, in all actuality, it doesn't really matter what you describe as B or A, or vice versa, but just make sure it's consistent. If I'm going to call 6B, that means that it's the same on the bottom, okay? But in this case, I called 6B, so I'm going to draw like a little thing here. This is B, and 3 is A. And so now I just put them in the function, okay? So if I say f of 6, okay, let me clean this up a little bit. I'm a little disappointed in the way this looks. This is not how I like the way it looks here. Kind of a neat freak, apologize. You can continue on until I get this done. F of 6 minus f of 3 all over 6 minus 3. Okay, so let's do some quick math. 6 minus 3 I know is 3. Okay, so I'm going to kind of put this, actually I'm going to move this right over here. I know I'm wasting your time, I apologize. I'm going to organize my space up a little bit. 6 minus 3. So this equals, let's talk about what f of 6 equals. Well, if I look at my graph, I've already graphed all the solutions to this. So when I plugged in 6, I look at my graph. Let's see, 1, 2, 3, 4, 5, 6. All right, and then what was my value when I plugged in 6? Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so when I plugged in f of 6, I got 9. Or when I plugged in 6 in the function, I got 9. And then when I plugged in, let's see, minus f of 3. Let's figure out what f of 3 equals. Count for yourself here. Let's see, 1, 2, 3. So when I plugged in 3 for x, I got 1, 2, 3, 4, 5, 6. So 9 minus 6 all over 6 minus 3, which in this case is 3. And so we just do some simple math here. We get 3 over 3, which means the average rate of change is 1. Now I'm going to show you guys something cool here. So we know that the average rate of change is 1. Okay. Now I'm going to do is graph the secant line. So watch this little thing here. So what I'm going to do is I'm going to go from the point 3, and I'm just going to follow this slope. Slope is a rate as well. So we're going to go up 1 over 1, up 1 over 1, And you can also do this to find the rate of change. If you think about it, the slope from one point to another is the rate of change. And so instead of doing necessarily all this math, since I have the graph available, I could just count the slope, how much I went up and over. In this case, I went up 3 over 3, which gives me 1 over 1. All right, but use the formula for right now in case that was a little confusing. So I know my secant line is the line, and this is kind of a little bit of stuff I'm preparing you for the future, is a secant line is the line that connects these two things. So let's just continue on. I'm just going to graph this line all the way through. And so, oh man, that's bad. Give me a second. I'm going to graph this. All right, that's the best we're going to get. That's supposed to be a straight line. Not very good, though. So now what we have here is we have a slope. We've graphed the secant line. The secant line is a line that goes through 2 points on the graph. In this case, it provides us with the average rate of change. And then I want you to write the equation of the secant line. A lot of this is review. So we know that the slope, so the equation of a line is y equals mx plus b. And we know the slope is, I know, it stinks. We're going back to this again. Y equals 1. The slope is 1x plus b. And so now we plug in 1, x, and y. So let's just plug in any point on the line. So let's just plug in 3, 6. So I just pick out one of these points. 3, 6 is on the line. And so I plug in 6 for y. I plug in 3 for x. And so I get 3 plus 3 plus b, 6 equals 3 plus b, and then I subtract 3, and so I get, sorry, let me make sure my work's going on top of each other. Minus 3, so we get 3 equals b. And you'll also notice that it crosses the y-axis. B is the y-intercept. It crosses the y-axis at 3. So you could have also looked at your graph there. And so my equation of the secant line is y equals 1x plus 3. So that is the line that goes through those 2 points on your graph. This material here is something I'm just kind of throwing in here at you, but the average rate of change is the important part, okay? So let's say, for example, so in that case, that was pretty easy because I had the graph to kind of help me out. But let's say, for example, I don't have the graph, and all I have is just a function, all right? Y equals x to the third plus 2x minus 1. What I recommend here is we're going to use the remainder theorem. And so let's talk about that. I know, we're bringing back the oldie but goodies. All right, we start with what our function is, degree 3 polynomial. So we start with 3, and we go in descending order. We fill in the exponents. This is 1. This is 0, because there is no x squared. This is 2, and this is negative 1. And what I'm going to do is I'm going to find the average rate of change from, let's say, let's go from 0 to, let's say, 4. So I want to find the average rate of change between 0 and 4. So it's pretty easy to find 0. Let me put this in here. Let's see. F of 4 minus f of 0 all over 4 minus 0. All right. And so what we're going to do is this is the function I'm going to use, but I have to find out what f of 4 is. So I'm going to plug this in using the remainder theorem here. 1, 4, 4, 16, 18. 18 times 4 is 72, I believe. And we get 71. All right. So this value right here is 71. So f of 4 equals 71. So 71 minus, if I plug 0 in for x, all I get is negative 1 all over 4 minus 0, which is 4. So the average rate of change that I just found is 71 plus 2, or plus 1, I'm getting ahead of myself, plus 1 over 4, which equals 72 divided by 4, which if you take a moment to figure that out, you get, if I'm thinking, oh, my brain's not working right now. Is that, I'm going to grab a calculator. Give me a second. Let's see here. Brain's not working here right now. Oh, let's go old school. It's probably, I'm thinking, let's see, 72. Let's just take 4. Let's do a little long division here. 4 goes into 7 one time. 4, 3, 2, 18. Caught up on me there. 18 is the instant, or not the instantaneous, the average rate of change from 0 to 4. All right, so that is my average rate of change. So I know I kind of jumped around this video, but understand that this is the key to the whole. This is the formula that we need to keep track of when we're finding average rate of change. And understand that if I were to apply this to a real life situation, let's say for example this is me throwing a baseball up in the air, and I want to know the speed, the average speed from after let's say 1 second to 3 seconds, I would know that the average rate of change of that particular function is 1. And obviously we don't really have a context of the problem, but understand that this rate of change finds that for every second it goes up 1 mile per hour. So the average rate of change is that. So knowing the formula here, take your opportunity and try to work those practice problems on your paper. Thank you and have a great night.